Hello, class. Okay, so I'm going to record a quick video on just how to use a spreadsheet to plot things. And we'll start out with a very simple example, like say we drop something and just measure the distance it falls as a function of time. So what I'm going to do is I'm going to make up data here, time in seconds, and distance in, say, centimeters. And let's say time, I'll just make this up. We'll look at like 0.5 second intervals. And now, if this was an actual lab, what we would, we'd have some errors in our measurements. So what I'm going to do is I'm going to calculate what it should be, and then I'll just make up numbers that take errors into account. So we know the answer should be 1/2 g. That'd be 4.9 times time squared. And this will give us a distance in meters. So to convert to centimeters, I'll multiply by 100. Oh, maybe we should just leave the distance in meters. Okay, so I'll get rid of that times 100. Okay, and drag that down, and it'll just, copy the formula down, but use the different time values for each one. Here, I'm going to make up numbers now for distance that are a little bit off from what they should be, because that's more realistic. So, okay, so now I'm going to delete this, and just say this is our actual data. And we want to let's say we want to plot this data. So let's highlight this. And now I'm using something called LibreOffice, which is like a free version of Microsoft Office. It's open source, and I actually like it more than Office. I do not like Office. But anyways, if you can figure it out on one thing, you can pretty much do it on another. So they all work pretty much the same. It's just the only main difference is like finding where things are. So here it's like insert chart, and then I'm going to pick XY scatter, and let's click next. So yeah, that looks good. I think we're going to get to chart element. So title, I'm going to call this free fall distance. So one thing you want to be careful about when it comes to a title, we're plotting distance as a function of time, and the easiest thing to do is just say distance versus time plot, but that doesn't really give us any information because we can already see that just from looking at it. So try to come up with a name describing what it is. So like we're looking at the distance traveled by an object in free fall. So let's just say that. Now on the x-axis, we have time in seconds. And on the y-axis, distance in meters. And now let's click finish. So we've got, the axes and units are labeled. And I've got this column B, which I don't want there, so I'm going to just delete it. Now that's great if you have, like, if you were to plot, you can plot multiple data sets on the same graph, and then having that thing that I just deleted is nice because then you can distinguish them. But I don't like it, and I also don't really like these huge icons. So what I'm going to do is highlight. So I double clicked on one of the data points to bring this up. And again, you don't need to do this, but I'm going to pick a different icon that's more circular and then shrink it. So just so it looks more like just data points. Okay. So here we have a nice plot showing our data. Now, if we wanted to linearize this data, which, like, in the example or online, we talked about the like how we could use this to find the acceleration due to gravity. I'm going to copy this I'm not sure if this is going to work actually, but no, it worked. Okay. So remember, we have distance is 1/2 gt squared. So actually, you know what? I'm going to delete this for now. And if distance is 1/2 gt squared, what I'm going to do is I'm going to label these x and y for now. And so y is going to be distance, so I'm just going to copy those numbers. Okay. So we're letting y equal d, and let's let x equal t squared. And then what we'll have is y equals 0.5 g times x. So y is d, and x is equal to t squared. So what I'm going to do, instead of calculating these, I'm going to just say equals this time value, and then that caret 2 for squared. So yeah, 0.5 squared is 0.25. And then what I'm going to do is highlight this and drag it down. And you can see like 3 squared is 9. Like here, this is a2 squared. And then by dragging it down, it just automatically goes down and, a3 squared. It's actually a very useful thing. So you can just type the formula once and then drag it down. And so now we should have linear data here. So I'm going to create another plot doing the same thing as before. So insert chart XY, hit next. I just want to get to chart element. I'll just say linearize free fall plot. And then on the x-axis, we have time squared. Now, this is one case where we have a little bit of an issue. Right now, I'm just going to do this. I don't know how to get exponents in this little box here. Now, if you really want to, you could just do like this. And leave a little space there, and then add a 2 later. Like, if I was going to do this for real, that's probably what I would do. Like, if I was going to type something up and have this attached, I would just do it like this and realize I have to put that exponent there later. And one thing you can always do is just save your image as a picture and then open up something like with like Microsoft, you can just open up Paint and insert whatever you want. So you could just put a small 2 up there and make a t squared. So I can't do it in this box, but you can do it somewhere else. And the y, we have distance in meters. Yeah, maybe I'll do that anyways. Okay. So we can see now our data definitely does look linear. And again, I'm going to double click on these data points. There we go. Icon, I'll pick that circular looking one and make it small. Okay, and we can get rid of that. So here's our data now. Time just t with a space there. I can put the exponent later. And now what we want to do is insert our best fit line. So here what I'm going to do is click on this data point again. Sometimes it's hard to tell the computer what you're trying to actually click on. But here, we got the data point. And now I'm going to right click and say insert trend line. And here we've got options: linear, logarithmic, exponential, power. We just want polynomial. That could be useful. But now we just want linear. And I also want to show the equation. And let's see, is there anything else? We don't want to give it a name. I'm going to do this as well. Show coefficient of determination, r squared. Talk about that in a minute. I'm going to hit enter. Okay. So here, this gives us our best fit line. And here we have 4.8. Remember, that's 1/2 g. So if we multiply that by 2 to get g, and then our units, remember the slope is meters per second squared. That should be times squared. Oh, yeah, I should have put a second squared, not a t. I can fix that later anyways. Okay. So yeah, 4.8 times 2 is 9.6, and then we'd compare that to the accepted value of 9.8, and now we have a fairly nice looking graph. Now, what is this r squared value? So we're plotting data that's not truly linear because there were slight errors involved. And that r squared is a measure of how close your data is to a line. So if we had an r squared value of 1, that would mean that all our data fell perfectly on a line. And, if you get away from 1, then that means that's just worse. Something kind of cool. Like, let's look at this data point here. That's this point here. It'll show you 42.5. What's nice is I can change this, and you'll see the data point will change as well. And now look what happened to the r squared value just from changing that 1 point. It went down to 0.79. It's now a much worse line. And let's change it back to what it was. It was 42.5. So it's kind of cool. You can change it, and it'll update the plot automatically. Okay. Now, I'm going to see if I can move this, just this equation. Maybe what I'm going to do is I'm going to write down the slope and intercept. Actually, I don't care about the intercept. I'm just going to write down the slope. Oh yeah, slope and r squared. The slope is 4.81, we'll say. And r squared is 0.997. So we've got those. And now I want to delete this. Oh yeah, see if I can delete that. Okay. And I just don't like the way it looked because it has way too many significant figures. So here's the plot. There are a few issues. I should probably capitalize this P because everything else is. Let's see. Let's see if I can type. Nah. I don't want to mess with that. All right, let's forget about that. So I want to fix this unit. So what I'm going to do, you can do this. You can click on this and just say, you should be able to just save it. Oh, we can't save it. You can copy it and then save it. Like you could paste it into like a Word document and then save it. So we can't do it directly. So we can do, there's this nice thing that I know like Microsoft has called the snipping tool. And I'm just going to do that and click new, and then you can highlight whatever you want. And here, and then I can save this. I'll just say, okay, so that's saved. And then I'm going to open it with Paint. Now again, you could just turn it in as it is. But oh wait, wrong thing. I want to open it with Paint. There it is. Okay. So what I'm going to do is I'm going to make it a little bigger or zoom in. And I want to fix this. So I'm going to erase T. That should have been a second squared. So I'm going to just erase that. And I'm going to type something in here. I'm going to try and type second squared. Here's what I'm going to do. I'm going to erase, not that much. I'm going to erase the parentheses as well. and just try this. So text box. And here, seconds. Then I'll leave a space here. Now we want to make this match what we had before, so I'm going to increase the size a little bit. Let's try 12. Nope. Okay, that looks reasonable. And then I'm going to make the 2 a little bit smaller. So we'll put the exponent up here. And I want that. Let's try it. See if that works. Now that's way too big, so let's try to make that like... Okay. So again, you don't have to do it. You could just have like second and then the caret with an exponent. But just to show it, if you want to do it, you can. There's always a way to do things like that. And now I erased that that f of x equals that whole mess with all those significant figures, and I erase that because I don't like it. So one thing you could do is just write, we can type it in ourselves. I'm going to say y equals, it was 4.81x. Make that a little bigger, but okay. To me, that just looks better. And then we can also put the r squared, although we'll have that same issue with the exponent, but there r, leave a little space for that. That was 0.997, I believe. Yeah. Okay. And then all we have to do is put the exponent. So size 6 worked pretty well for that. Okay. And so there's our plot. And yeah, I should have made that a capital P. I could just erase the whole thing and type linearized free fall plot. So why don't we do that? And then I'll make it kind of the same size as everything else was. So here I can move it around as well. It didn't work for whatever reason. Oh, because I'm still in the text box. So what I'm going to do is I'm just going to select this and kind of recenter it. We can also give it a name as well, like plot 1. It's always good to do that. I probably should have done that. But again, you can see like, you can do whatever you want with these plots. You can save them as images and modify them and so on. So don't feel like you're restricted by what the spreadsheet allows you to do. And yeah, that's pretty much all we need for this plot, other than I should have probably called it plot 1, but that'd be easy to do. And just text box and type it up. And then what I would do is save this, and then I could put it into the lab report. So yeah, different programs will have slightly different ways, but usually it's just a matter of how you find things. Like here, like right-clicking on the data point to find the insert trend line. I'm not sure if it works the same way in Office or Google Docs or whatever, but just by playing around, you can figure it out. And if you really get stuck, you could probably just type the exact question you're looking for in YouTube, and someone probably answered it. The only issue you'd most likely have there is when they update things, sometimes they change it. So if it's an old video, it might not work anymore. But yeah, you can always figure these things out. Okay, so again, if you have any issues making plots, yeah, just let me know. We can always talk about it online or by email or whatever. So that'll be it for this.